Okay, so hello and welcome. And we're going to start with a problem that you probably all encountered in some form or another one day at some point. And that's the problem of having a report and summarizing by day. So what we want is show every single day and say a count and a total value of the orders for each day. But there's a little wrinkle. There are some days where no orders were placed, but we still want to see those days even if there's 0 orders. So like I say, this is a common problem. It doesn't just apply to like order summaries, but things like meeting calendars or event calendars, anything where you want to show something by date and you want to count or sum or whatever that thing by day. There can be gaps in your data. So what we need to do is get some dates. So essentially, to run a query like that, we need to do something like this. We need to have a table of dates and outer join our orders to that on the matching date like this. So the question now becomes, well, how do we actually get those dates? Where do those dates come from? So this is something that crops up in various forms and another on Ask Tom fairly frequently. So what I want to do is talk about that in a bit more detail today. So hi everyone, I'm Chris Saxon. I'm part of Gerald Venzel's developer advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, it's always great to be here for these SQL office hour sessions. As always, the point of these is for you to ask your questions, hopefully and help you learn a little bit, but also if you've got questions about this topic, please let us know. Put them in the question and answer window, not the chat, in the question and answer window. Just makes it a little bit easier for me to manage. And we'll have some time for ask questions at the end, maybe, hopefully. So what we're going to do is look at ways we can generate days in between 2 dates and also variations on that problem, things like generating months as well. So let's get started. So the first question is, how do we actually generate the days? Well, that's pretty straightforward. We can use this lovely little trick, which most, if not all of you, have probably seen, if not are familiar with in some form or another. So what we've got our dual table, it's a special one-row table in an Oracle database that always exists. And we can use this connect by level trick. And what this does is generate up to n rows, or the rows from 1 up to n. The level is kind of how deep we are in the tree. We're kind of abusing this feature slightly to get n rows in our data set. We can use this as the basis of a generate n dates in a time period, or generate n days. So instead of just using our level, we'll have a start date. So we'll pick the 1st of this year, for example, and add the level onto that. Now do note, of course, the level starts at 1. So we have to subtract 1 from the value we are using. Otherwise, we'll start with the 2nd, right? If we want to have the first date in our period, we need to add the level and subtract 1. Otherwise, we're always going to be 1 day out. There's lots of other points in this where you need to be careful of off by 1 errors like that. Are you including the end date or excluding the end date? I'll cover those as we get to them. So we can use this connect by level trick with dual. And the reason I use dual, like I say, it's a table that's in every single database, and it's optimized for fast access. So there's minimal overhead for using this. But we don't have to use dual here. We can use any one row table that we want. You know, anything where we're sure there's going to be exactly 1 row in the data set. It's rare you'll have that as a physical table in your database, but there's some situations where you might have it. So let's look at this slightly different variation on this problem. So what we want to show the orders, daily summary of orders in a table, but we don't have a fixed start and end date. We just want to go from whatever the date of the first order in the table is to whatever the date of the last order in the table here is. So it's kind of like a dynamically generating. As we add or remove rows from that table, the size of the start and end dates will change accordingly. And we don't want to have to hard code that in the query, right? We just want the query to pick it up automatically from the data. So how can we do this? Well, how do we find the oldest and newest date in a table generally? Well, we just use min and max, right? Min, smallest date, earliest date, max, the oldest date. And we can then use this to then generate the rows out between them. Because we're just getting one row in the output, so we've got two columns, but that will be summarized into one row in the results. So instead of using dual, we can actually use this as the basis to generate the rows that we're going to use. So we can say, stick that in our with clause, our named subquery, call it rows, for example, here. And then we can use those start and min dates and max dates to generate the rows out. So we start with the min date, add on our level -1, and we generate all the rows between those two dates. Again, +1, watching for the off by 1 error. If you don't add that 1 on the end, you'll go from the first date up to but not including the end date. Usually you want to include the end date in that as well. So we can use this then, and then whatever values are returned by that subquery, the size of the data set will grow or shrink appropriately. We'll just get one row for every single day in the range from our minimum to our maximum.
I said we could find the oldest and newest dates in the table, work across the entire data set. So, if your company's been around for a while, that could be, quite a long time, a lot of dates we're generating here. But we could also use it for a particular subset of the data. So for example, say for a particular customer, find how many orders they placed each day between the first order that customer placed and the last order they placed, or a particular store, particular location, what's the oldest and newest dates. So we don't need to kind of like hard code what our oldest and newest dates are here. We can actually generate them from the data set itself, which can be particularly handy in some scenarios. So, but the principle here is the same. We've got our one row table, and this stores the maximum and min dates, and we are generating a row between those values. So that's pretty straightforward. I said there was some kind of subtle variations on this that we could try out. So let's start with one that cropped up a little while ago. So someone wants to see every Monday of the year. So rather than seeing every single day of the year, they want to see just a specific day of the week in a particular year or in a particular month, for example. Now, in order to do that, one approach we could take is just kind of like, let's just generate every single date in the range. We'll start from find how many days there are in the year and create a row for each one of those, and then filter the data set down to just the rows that are Mondays, right? Seems pretty straightforward. Easy enough to write, but there's a big problem with this. We are generating 365 rows and filtering down just to 52 rows. So we're creating about 7 times as many rows as we'd like to. This is not really a good approach. If I saw this in some code, I'd be like, yeah, I'm not kind of angry or upset about this. It's like, I'll do the parent thing. I'm just disappointed, right? I'm just disappointed to see something like this because we're doing more work than we need to. In general, a good principle with SQL to follow is only select what you need to do the job. Only select the information you've got. Now, most of us, hopefully, are pretty familiar with this when it comes to the select clause. Avoid select star, because we only select the columns we need, but you only want to fetch the rows you need, the rows you're actually going to process further on in the data set. If we only want the Mondays, then we're creating 7 times as much data as we genuinely need. Now, in this example, it's probably not too big a deal, right? 360 odd rows is still pretty tiny by modern database standards. We're going to process it pretty quickly, but potentially this might slow things down more generally. If this is a much larger query we're working with, we might end up working with 7 times as much data throughout the query more often. So it's a good general principle to filter early. Only select the rows you need. Make sure your where clause only identifies exactly what you want. And when it comes to generating data like this, we only generate out the rows we need. So rather than getting our full year, filtering it down to just the Mondays, Well, let's figure out how many Mondays there are we need and only create those. So how many Mondays are there in a year? Well, the way we can find that is say, well, what's the last day in the year, 31st of December, and subtract off the date of the first Monday in the year. So we can find how many days there are between them. On the number of weeks we need to generate then, because we're generating basically a row per week that contains a Monday in 2021, we can just divide that value by 7, take the floor of it, so we round it down, and add 1 week as well. You know, off by 1 errors we need to watch for as well. So this is kind of the principle that we're going to do. So we can use this to only create the rows we need rather than creating more and filtering down after the fact. So the first question here is, well, how do we find that first Monday? Okay, so there's various tricks you can use. The one I'm going to use here is this next day function. So pass in a date and a day of the week, and it returns the day of the week, that day of the week, the date it falls on after that day. So a couple of things to note here. You notice I'm subtracting 1 from the 1st of January. That's because if the 1st of January is a Monday, it returns the Monday after that. So it's looking for the next Monday after the current date. We want to ensure we include the 1st of January, you know, just in case it is a Monday, we need to subtract 1 off of that. Go back to the 31st of December and find the Monday after that. So again, be careful with this. Make sure you're having the correct starting point for the date of the day of the week that you actually want in the result. Next thing is, you see I've written Monday in English. So this is uses the language of your session, the session's NLS language settings. Unlike some of the other date-related function, there is no NLS parameter to control this. So you need to be very, very careful here, you know, particularly those of you who work with applications with multiple locales and different current language settings and country settings and so on. You can find this behaves a little bit unexpectedly. You know, if you've got it set to Spanish or German or whatever, you need to make sure you're using the day of the week in that language. You can't just always pass in the English language, and there is no way to avoid this. Okay, so sadly there is no third parameter where you can strictly specify the NLS language that you use. So we found the first Monday. Next thing we want to do is find how many days there are between that and the end of the year. So we subtract the end of the year, that from the end of the year, and then we need to convert that to weeks. So you see here I've got add 7 and then divide by 7. 7 days in a week, so we just normalize that through to weeks. So again, I'm adding 1 here because if the first day is a Monday, there'll be 52 weeks, and then the last day is also a Monday, so we need to include that extra day as well. I'll show some examples of this just to kind of prove to you why you need this and so on and so forth. And then finally, we can use that. That tells us how many rows we're generating, and we can then create our data set. Again, we'll find the date of the first Monday, pass in our start date, subtract 1, and then add on 7 days for each row. So we're adding on a week. So there isn't a time period of a week defined in Oracle database. Fortunately, it's just 7 days, right? We just add that, multiply that up by 7 to see how many rows we're going to get. So far, fairly straightforward, hopefully. Any questions or comments on this? What about trunk date to the ISO year? Okay, that's a good question, Judith. So you need to be careful when there's various other trunk functions you can use. So if we're looking for the first Monday of the year, trunk of the ISO year is not would return you a Monday. That's true. But what if we want a different week? What if we want a Thursday or a Friday or things like that? We need to be careful. Also, the first day of the ISO year can be in the year before, okay? Because the ISO year starts in the first week that contains a Thursday. I think pretty sure that's the definition. And so sometimes the ISO week for a year starts actually the year before. You need to be careful when you're doing things like that. So there's all sorts of ways of approaching these things. You just need to test very, very thoroughly because, like say, things like leap years, things like ISO years starting and ending in a different year that they actually fall in, are all problems that do occur. So you need to be careful when doing things like that. It's kind of why I haven't really used it here. I haven't used the ISO year because is it 20? I think it's 2020. The ISO year actually started in 2019. Okay, so you need to be careful when doing things like that. All right, so that gets us a row per day. What if we want, and we can see row per day, row per week. So row per week is pretty straightforward. We just kind of multiply everything up by 7, multiply and divide by 7 as needed. What if we want something a bit different? What if we want a row per month? Now, a month is not a fixed unit of time, right? The number of days in a month varies between 28 and 31. So we can't just add on, you can't add on the average or something daft like that. You need some, if you're going to try and hand code this, it gets very complicated very quickly. Something I don't think any of us really want to do, right? So there are better ways of doing that. So let's generate a row per month in a given year. So we can do something like this, and we can add months. We can use the add months to add those number of months, and this works correctly in terms of adding on to the point the next month. So we pass in our start date, say how many months we want to add based on where we are in the data set, and we will adjust things appropriately. Now, one thing to watch with this, I'll recap this again a bit later. It adds a month or n months and gets you to the same day on the target month. So if we start on the 1st, add 2 months, we'll end up on the 1st of the target month. But if the add month starts with the date of the last of the month, we then go to the last day of the next month. All right. So if we're in, we're in March, if we're on the 31st of March and we add 1 month to that, we will get the 30th of April. Okay. So again, subtle thing to watch out for there in terms of how you want to behave. We can then use months between as well to find how many different months there are from that start date to the end date. And that will give you whole number of months in a fractional. And again, this uses the last day of the month to be a whole unit. So if you subtract or you find the months between the 30th of April and the 31st of March, that is considered to be a whole month because they are both the last day of that month. Okay, so that's fairly straightforward. Hopefully, caveats about which day of the month you want. What about years? Okay, so what if we want to add years? Well, we could add 12, multiply it up by 12 months. We could also use intervals. We could use a year to month interval and add on how many years we want to do that. Now, at this point, you might wonder a little bit, why have I used intervals here, but not with months? Well, when you add an interval, it always goes to exactly the same day the next month, okay? So if you add 1 month interval to the 31st of January, it tries to go to the 31st of February, which of course never exists, right? So you'll get all sorts of errors. So adding intervals with years can work. Actually, I have to check with the leap years exactly what happens, but adding intervals with months can cause all sorts of horrible problems. And you'll run into this constantly. So adding intervals with months is risky. I'd stick to add months. Bear in mind, you need to think carefully about how end of month handling happens as well. Okay, so we've kind of generated out our days. Let's say we've generated months or whatever it is. What people also want to see is they say not just a row per month, but show the start and end date for each month. For example, a table is something like this. So we can see the months and the start and end dates for them. Now, there's a little interesting wrinkle I've done with this. You'll notice that they start and end on the same day, on the 15th. But instead of making those start and end dates for each month, the 15th or the 14th as well, they start on the calendar month and start and end days, right? So we start, our time period starts and ends on the 15th, but the days in between are the first day and the last day of each month. So we can use the principle we're doing to actually get them on the same day of the month if we want, but sometimes, you know, people do ask this, start day is fixed, end day is fixed, but we need start and end day of the month for the rows in between them. How do we do something like that? Okay, so we can have our month generation query. So that's the one we had before, put it in the subquery, and they will select from that. So what we want is, if it's the first row, get the value we passed in, basically. For every other row, get the first of the month. So we can do that with a case expression like this. So you can see when the row num equals 1, we'll get our date. Otherwise, we will trunk the date, and we're using the month format to get the first day of that month. So that gets the start of the month. So as we see, we can pass in, as we were talking about a second ago, you can actually pass in all sorts of different format masks to trunk. By default, it just returns the date without a time, kind of effectively strips the time component off, but we can also trunk it to month and year and things like that as well. So that gets us our start dates. What about our end dates? Well, a nice way to do that is to use the lead function. Look at the date for the next row, the start of the month for the next row, and subtract 1 from that. Now, normally, when working with intervals, time intervals, what you want is closed open intervals. So including the start date and everything up to but not including the end date. So this means that the start of one time period equals the end of the previous time period. So they're exactly the same value. However, for reporting purposes, quite often people want to see that gap between them, right? They want time period to start on a day, end on the next last day of the month, and the next one to start on the first day of the next month. So when it comes to calculations, I wouldn't do the subtract 1. I would make sure they are in fact the same value. Otherwise, you can end up with all sorts of off by 1, missing out values, and so on and so forth. But for display purposes, quite often you do actually want one row to be the last day of the current month and the next row to be the first day of the next month. Okay, but what we're doing is using lead to look forward in the data set, find the first day of the next month, and take 1 off that to get the end of the current month. But then what happens when we get to the last row in the data set? So we've got to the last row in the data set, we look forward, there's nothing there. So what value do we return? So that's where this final parameter for lead comes in. So 1 is telling us to look forward 1 row in the data set, and the final parameter set is the value to return when we go beyond the end of the data set. So in this case, we've reached the end and we just want the value we've generated for that row. So it will be the same day of the month as whatever our day of the month our first row in the data set was. Right, so hopefully at this point you're thinking, pretty neat. There's lots of little tricks we can use to generate these values out and lots of ways we can look at them. Can we find a way to make these reusable? Now, those of you who've been joining these sessions for a while now will hopefully know what I'm going to say at this point. SQL macros, right? So these are a great way to create reusable SQL fragments or SQL components, which you can build up into larger queries. I've talked a lot about SQL macros before, so I'm not going to go into big details about them today. But I will just say we can use this, for example, to create a generate days function, and we'll generate the values between start and end, say what our increment is. And what we do there is return the text of the query that we want. Essentially, think of this like a query template. And when we call this, the database will search for the parameter values in that string and actually substitute in the exact values we passed for those parameters. So at this point, I'm going to jump over to a little demo. I see there's a couple of other comments. Niels, views trunk date, you always get the first one. So you mean trunk date ISO week? The first, if you get the, I'm going to check that, Niels, because I could be wrong, but I'm pretty sure the first Monday. Okay, if you take the 7th of the month. Okay, if you're the 7th of the month, you're probably all right. You need to do some fiddling there, potentially, though. So, yes, I think you're right, but we can discuss this and check it in a bit more detail, because we're going to jump over and actually try some code out. But, yes, the 7th of the month will always be in the start of that ISO week, and the first one will be a Monday. Good point. Alrighty then. Any other comments or suggestions, questions before I start going into the demo? Nope. Okay. Alrighty then. So I'll just rattle through these first ones a bit quickly because it's just kind of showing you what was on the slides. We can use this to generate 10 rows. Like I say, most of you are probably pretty familiar with that. Oop, that's not what I want to press. We can use that to generate 10 days. So the first 10 days of the year to the 10th of January. And we can generate all the days in the year by saying 365. So I get, and eventually we'll see, got the 31st of December down at the bottom. Okay, so that's great if we know how many days we want to generate, or we've got specific start and end dates we want to work with. But what if we want it to be data driven? Like I said, actually work off whatever the smallest and largest values are in the table. So we saw an example like this, that gets us one row, our start and end dates, and then we can pass that to another subquery, which will actually generate the values out. Now at this point, something a little interesting going on. You'll see instead of just subtracting them, I'm using this extract function. Why have I done that? Why haven't I just subtracted one from the other? Well, these are timestamps. This is the customer orders schema that we released a couple of years ago. The date times here use timestamps and not dates. When you subtract one timestamp from another, you don't get a numeric value, you get an interval value, okay, an interval data second. So that is not a number. We need to extract out how many days there are in it. So again, another one of these little gotchas or things you need to look for. Be careful if you're working with dates and timestamps. If everything's just a normal date type, I mean, mostly this works. As soon as you start getting timestamps, when you start playing with timestamps with time zones, it gets even more interesting because you've got to think about what happens with things like daylight savings, what constitutes a day, and so on and forth. I'm not going to get into all those details at the moment. We'll just keep it nice and simple, but there's all sorts of edge cases all over the place, right? Working with dates is hard. Okay, anyway, we can use that to generate, find the minimum max, generate all those rows, and then join it to the orders table itself. So there we can see whatever the first day. So the first date's the 4th of February, 2018, down to the 12th of April, 2019, and gives us a row per date. And as I said, we can actually kind of pass in any subquery here, really, we want. So I can find all the orders for a particular store, so this particular location, and then pass that to my subquery like this. And then you can see we've been doing all sorts of crazy things here. I could have put this in its own named with clause as well. I'm just showing you different ways of doing these kinds of things. They all amount to the same stuff. A lot of it comes down to personal preference, how you actually want to do it. So we can see for this store, what is the oldest and newest orders, and generate a row for each one of those. And you can see the data set's much smaller here. We go from 22nd of March down to the 12th of April. And if we add or delete rows for this, then the size of this data set will grow or shrink appropriately. Now, one of the, if I go back down to this one, one of the nice things about, well, one of the reasons for using a subquery to do like this is, as I said, we're now only selecting the information we need to actually process the query, what the location is and what the dates are. So that's all we need. We've just got that. We are filtering early and we're reducing how much work we're going to do. But we can see we've actually used this store subquery a couple of times elsewhere in this statement. And the optimizer can spot this and kind of go, well, hang on, I'm doing this thing a couple of times. Instead of recalculating it, going back to the table and running it many times, querying the same table many times, well, why don't we just save the results, right? And we can materialize that query. And you can see it's got this lovely thing called a temp table transformation, and this systemp thing. So this is kind of like a generated temporary table. It's created, and you can see it's referenced it a couple of times elsewhere. So doing something like this is particularly useful, potentially quite useful. Not only do we make it easier for the optimizer to use an index, good chance that we have an index on store ID and order already. You know, you might already have an index like that, so we can just read the index rather than the table. But also, it can save the results of that and avoid having to go back to the table or index multiple times. Okay, so there's an example of using it to kind of just work off unknown dates, just using source data. Let's see, let's look at our example where we are generating and then filtering. So we're going to generate all the rows in the year and then filter down to just the Mondays. So we're doing more work than we need to. Or we can generate the rows we need, and we can generate just the rows we need. So I want to work with Fridays. So the first of this year was a Friday. So that means there's 53 Fridays in this year. So you can see we start with the 1st of January, and we have got all 53 rows. We go through to the 31st of December, okay? If we go for Saturday, there was only 52 Saturdays in this year, so we're only going through to the 25th of December, so we're picking up things appropriately. So, you know, we say, as Niels and Judith are saying, we could use things like trunk the ISO week. You need to think carefully about which day of the week you want, make sure you're using the correct values you are mapping through and doing those appropriately. Okay, on that point about next day, as I said, it uses the NLS language of your session. So if I change my session to Spanish and I try and pass in Friday, it's going to blow up. It's going to go, yeah, that doesn't work. Don't understand what that means. If I change it back to English again and go for viernes, which is Friday in Spanish, again, it doesn't spot this. So you need to be very, very careful if you're going to use this next day function. It is very handy, but as I say, you do need to be very careful about making sure you are consistent with NLS settings. Otherwise, you will get all sorts of unexpected problems here. Okay, very quick example, just showing the add months. We'll say we get a month of the year. Here's generating a particular day of the month, so the 15th. And here's the one where we, I was doing that start and end date table. So each month we have this first date, last date, but also working with whatever our start and end dates are. So the 15th of Jan to begin with, 15th of Jan again to end with, using those lag and lead. And here we are using years instead. Okay, so these are all nice, right? But it would be nice to not have to think about this all the time. So let's create our SQL macro package. So I'm creating a function for each unit of time we want to compute. I could try and create like a mega function, which just does generate periods. We pass in start and end dates and what kind of period you want. It's kind of it's going to be complicated to write and debug, you know, particularly with SQL macros, you're getting the text of the SQL back and then have to figure out that's doing what you want it to do. But also when it comes to using it as well, it's just clearer. I'm calling my generate days. I want to generate days, I call my generate days function. I want to generate months, call my generate months function as well. So not only does it make it easier to write these things, it makes them easier to use later on. So when you come back and say, why am I generating? What am I generating here? Why am I generating it? You can do that, figure that out appropriately. Okay, and I will then create macros. Notice it is text here. It is a string, because what the database is going to do is essentially return this text to become part of the final SQL statement, swapping in the parameter values that we pass. I've done dbms output here just to aid debugging and help people see what's going on. You wouldn't really use this in production code though. So let's create those and see the months and years and so on. And we can now use that to generate our days. Pretty neat. So we can see all the days in January. We can use it to generate every Friday of the year. So I'm saying, what's my first Friday of the year? Pass that in, and then have an increment of 7 days a week. We could do for Saturdays as well. So that should generate as our 52. We could do some things as well, like generate 1 row of fortnight every other Monday. We can, as long as we've got a fixed unit of time, we can do that. We can do every 10th day, whatever you want, really. So this is pretty handy. So there's a couple of comments I'll see. Let's just have a look at those. So Rachel, is there a function that can be used in a SQL statement to make sure that the NLS language is English? Well, there is not a particular function you can use to ensure it is. A lot of the conversion functions like toDate, toChar and so on do have an optional parameter where you can pass in NLS settings, the NLS date language. And that's when you're doing toDate and toChar conversions, that's what you should use, right? But I'm not aware of one where you could call it in a function and like throw an error if it's not the right language, if that's what you're getting at. Yeah, you can check the setting by just query the NLS session settings, but I don't know of one that would ensure it is always that. You'd have to alter the session. FJ, could you share all those scripts? Yep. Scripts from NoSQL, I will share a link to that up later. So Judith, you can use next day date end with a week day number instead of name in SQL only. Okay. So you mean, so let's see that, Judith. So let's see. I would, so we do next day n, you mean? So if we do something like that, what date is that giving us? The 4th of January. What does the 3 give us? Okay, so yeah, okay, that's cool. Didn't know that. Bear in mind again, different countries consider different days to be the first day of the week, right? The US considers Sunday to be the first of the week. A lot of the rest of the world considers Monday to be the first of the week. Some countries consider Saturday to be the first day of the week. It's, this is where using these numbers don't actually necessarily save you from this problem, right? They just, in some ways, perhaps even mask it a bit more because it's not immediately apparent to everyone which day of the week one is, all right? So bear that in mind as well, okay? Alrighty then, don't see any other comments at this point. And so we can generate out the years as well. I'm not sure. Okay, so this is one thing, I was saying that with add month, we go to the last day of the month. Now, the one case where this might be interesting for you is if you normally work off the 28th day of the month and you're in February, right? February, most years, only has 28 days. So if we pass in the 28th of February, notice that these are all now the last day of the month. What if we wanted it to be exactly the 28th day of the month? Okay, that's okay. We need to think about what the correct handling here. This is where you need to understand what it is you're trying to do. In cases like that, you're probably better off adding 4 weeks, 28 days, rather than trying to, actually, even that won't work. Sorry. You just got to understand what it is you're trying to do and why. So if we see, if we go to the 27th of February, we get the 27th, go to the 28th and we get the 28th. So, and if we go to the 28th of January, you'll see everything is now the 28th. This is, like I say, when it comes to date time calculations, you can never do too many tests because there's edge cases all over the place and things you can run into here. and we can generate out our years as well. I've repeated my example here where we're getting the max min dates using the generate days function, because I've actually had to kind of cross join it here in to actually get those values out. Okay, I rattled through a lot of those examples pretty quickly. Anyone got any other comments or suggestions or questions about those before we move back on? If we go back over to the slides for a minute, the comment or the point that I expected some of you at this point are thinking, I'm not on 19C. So like SQL macros or table SQL macros are a 19C feature. I'm willing to bet that most, if not all of you, are not working on 19C. So you're like, this thing doesn't work for you. Okay. So what do you do if you're not on 19C? Plus, there's another little wrinkle here that I haven't talked about yet. And that's, so far I've assumed you want to get every single day or month or whatever it is in the range. What if you only want business days or working days? Now, this is where things get even more complicated, because although what constitutes the first day of the week changes based on your locale, at least it's kind of well defined. You can find a Wikipedia page or some official document which will tell you what the first day of a week in a particular country is, or which day of the week, which number each day of the week corresponds to for a particular country. What constitutes a working day depends not only on which country you're in, but what rules your business follows, right? A lot of places consider the weekend to be non-working days, but some do. And then there's public holidays, which vary by country wildly. Again, is that a working day or not a working day? Interesting. How do we handle this? Trying to do all that in a SQL query that's generating out these values, excluding non-working days, is pretty tricky. So at this point, I'll go to a quote I really like. So what we're trying to do is figure things out so far. And as Ken Downs says, a code grinder is someone who's going to figure it out, while database programmer is going to spell it out. So far we have been figuring it out. We've been trying to write SQL statements to generate the values we want. Good way when working with databases is to kind of think, well, instead of calculating every single time what we want, just pre-calculate what we're looking for, store it in a table somewhere, and then use that as the basis for our calculations. So having talked loads so far about generating and ways you can do it and make it reusable, I would suggest you probably don't want to do that. What you probably want to do is create a dates table, actually store the information in a particular table. So I've got an example here called calendar dates. A couple of little interesting things I've done here. First up, we've got the check constraint for the date itself. This is the primary key. Checking that date equals the trunk of the date. Why have I done that? As I said, in Oracle database, the date data type always includes a time. So if we don't do this, we could have a row per second of each day, right? We don't want that. We want to ensure we've only got one row per day. And by convention, a date with no time is midnight. It's a date at time of midnight. So we want to check that the values equal that, prevent us storing multiple rows for a day. Second interesting thing here is I made it an index organized table. So what is that and why have I done that? Well, with a standard table, you've got two data structures for the primary key. You've got the table itself and the primary key index. So when you look up a row, you have to first go to the index, and assuming we want columns from the table itself, go to the table itself as well. With an index organized table, we take those two data structures and combine them into one. So the index is the table. The primary key index is the table. So this saves us a little lookup as well, but also because the values are our primary key, date values are all going to be next to each other in the index. Quite often when searching dates, you search a range of dates, a particular month, a particular year, that kind of thing. By ensuring they're sorted by that primary key, the date value, you can make things nice and efficient as well. So I've got another little demo to run. Actually, I saw there's a whole bunch of comments in the chat, which I missed earlier. So if you've got any other questions or comments as well, put them in while I just go back through what people were saying in the chat. Rob, before anything, by design, decide on the meaning of stored end dates. Do they include or exclude the time period? Very well said, Rob. This is going to cause you endless confusion if you don't, and loads of off by one errors. Make sure everyone knows it. Make sure you document it. When I was creating these functions here, you might even want to put it in the name of the function. Potentially, you could like create a generate months inclusive end dates and exclusive end dates, and actually put that in the name so that people know what's going on. But yes, make sure it is well understood by the entire development team what end dates actually mean. Faith, I wonder what trick you would do if it went with clause. That's a good question. Well, I mean, SQL macros is probably my trick I would go for a lot of these things, but yes. The with clause is insanely handy, and I find it very useful for both writing queries and also understanding them later. Okay, so Taddeo, do index organized tables exist in autonomous database? As far as I'm aware, they exist in autonomous database. Index organized tables are just part of, you know, standard Oracle SQL. They're not like any kind of extra cost option or anything. So pretty sure the answer is yes, but you know, I'd have to double check that. Okay, no other comments, suggestions. Let's look at our dates table quickly. Okay, so let me just drop the table and create it again. So you notice having the date, I'm storing whether it's a working day. Don't have a Boolean yet in Oracle database, unfortunately, so I'm having a check constraint. And I'm also storing what day of the week it is. I've just done this here, but you might also want to store things like month of what the name of the month is, what the number of the day of the year, what the number of the day of the week is, and so on and so forth as well, because then you can just put it in your queries. Any of you who've worked on data warehousing systems will almost certainly have seen these calendar dates tables or something like this with like a gajillion columns on it for all sorts of computed things. We've got the stuff we can derive from the date itself, but also things that we can't. Things like fiscal year. When does your company's fiscal year start and end? Depends on the company, right? And again, it can change. So let's store in some values. And we were talking about NLS conversions. I'm protecting ourselves from that. I'm using this with toChar. So basically I'm saying that Saturday and Sunday are non-working days. To avoid any NLS confusion and mix up, I've passed that parameter there. So let's store all the days of the year. I live in the UK, so I'm going to use that as the basis for my non-working days. So these are all the public holidays in the UK this year. So let's just save those in and get stats. So we can find all the Mondays in the year, start and end dates, which day of the week we are looking for. Pretty straightforward. Nice and easy to write this query and use. But even better, if I only want to find the working days, I'm just going to add this filter on the end here. Very simple. So we can see gone down to 47 working days, working Mondays in the year, rather than 52 Mondays that there actually is in the year. So the good thing about this is, like I say, what constitutes a working day will vary depending on your business. You can give this control to your admin, an admin in the business. Give them a simple screen to update this. So if a new public holiday is announced, or the business changes its rules and decided that everyone's got to work on a Saturday for some reason, you don't need to go and change your code. Someone just needs to go in and set this flag, and the query will pick it up automatically. We're making things data generated. Gives better control to the business, less code for us, easier queries to write. I mean, there are situations, just overall, it's a winner if you ask me. Okay. So one other reason that I just wanted to highlight quickly why you might want to use a real physical table as opposed to SQL macros or the connect by level trick. So here's my table, and I'm generating 4 weeks, so 28 days worth of data. And the optimizer knows that roughly, I mean, cardinality of 29, I'm getting 28 days. It thinks it's getting 29, but that's close enough. It's estimating that pretty much bang on. But if I go and use my SQL macro, it's actually it's one I had earlier, but hopefully it's still there. Yeah, it's estimating just one row. Okay, it doesn't know that this is expanding out to 28 days. Okay, so when it comes to these connect by level tricks, often the optimizer struggles much more to get the correct row estimates, and this can have disastrous consequences for plans. The better these estimates are, the more likely the optimizer is to choose the right plan. Particularly if it thinks something's getting one row, there are certain optimizations which only really work if you're actually getting just one row. As soon as you get any more than that, then they get to performance falls off a cliff pretty badly. As we can see, it thinks it's getting one row here, but actually we're getting lots. Whereas with my real physical table, well, we can gather the stats out of that to our heart's content and get pretty up-to-date, accurate representation of what's actually going on here. Alrighty then, we're getting to the end of what I had to cover, so let's just see. Rachel, what's the best way to check if there are any holidays in the next business week? The best way is, again, what do you mean by a business week? When does a business week start? Does it start on Monday and end on a Friday? Or do you mean Monday to Friday, Monday to Sunday? You've got to think about, be very careful and define exactly what you mean by business week. But the best way would be to have a table like this, have a table, and again, this is where you might want to separate out non-working days generally, so exclude weekends, and things that are specific holidays, things like Christmas Day, May Day, bank holiday, that kind of thing. Do you need to distinguish between what those are? So if you are asking here, is there in the next Monday to Friday time period a non-working day, we can say, is working day equals 0, whatever your start and end date ranges are. Maybe check that the values are Monday, Tuesday, Wednesday, Thursday, Friday as well. You need to be really precise about what you mean. And if you are not, eventually someone's going to get a result they didn't expect with this. Okay, you just need to think very carefully about it. Monday to Friday. I assume you mean Monday to Friday by that, Rachel, and not male to female, right? Okay, there's all these edge cases, and everyone defines it differently. Every country defines it differently. If you are not very explicit about what you want, at some point, someone will get a result they didn't expect it to be. Okay. All right. So I don't see other questions or comments at this point, so I'll just wrap up this point. So just recap quickly on that generate versus store. I start off using the connect by level trick and so on to generate the values, and then I'm saying, well, why don't we store them? So why would you use one or the other? Well, the big advantage of generation is you can always do it. You don't have to rely on a pre-existing table, and you can generate it for any single date that you want. Often you may work in environments where you have limited ability to push new tables into production, right? Either you've got to go through endless paperwork, or you just don't have time to get it out there for whatever reason. So sometimes you might be forced down the generation path. That said, if you can store them specifically, creating these days is a kind of one-off thing, which will almost certainly reuse many times throughout your application. The big benefits is whenever you've got any exception days, what counts as a working day or a non-working day, what the start and end dates of your working week, that kind of thing, you can just have columns in the table and an admin screen to actually manage those. So less code changes, which means that less work for us, right? But it also means the business don't need to wait for us. They can adapt and change things as needed. Also, quite importantly, or potentially very importantly, the optimizer has better information about how many rows we're actually going to get, which can make a big difference in some cases. Big downside of generation is kind of, the business doesn't have control. If there's any change to what constitutes a working day, or we need to change which days of the week we include or exclude, there's a code change. That's more work and slows things down. Now, that's not to say we'll never have any code changes using storing values. I say we might want to add extra columns in there to do things like calculate not just calendar year, but business, company fiscal year, country tax year, that kind of thing. Also, we might want to have a dates table per country, so you can store the working and non-working days for each country. Potentially very important if you've got employees in different countries of the world, right? So you can calculate their holiday allowance correctly. So that's not to say storing will never have code changes, but there are much fewer, and they tend to be a one-off piece of work, and then you can give control to the business. Big drawback, however, of storing data is it's always possible that there's some dates missing, right? With generations, doesn't matter what our start and end dates are, we can always pull them out. You've got to ensure you've got enough rows in that calendar dates table to cover every conceivable value you could need, okay? And this, it pays to be defensive with this and just kind of generate a whole bunch of values. So you want things from the dawn of time for your application, whatever that means. That could be when your company started business, could be when the application went live. If you're working with things like people's dates of birth, you might need to go all the way back to start of last century, 1900, and generate the days from then till now to ensure you calculate, showing things like when people were born, that kind of information. So you need to go back from whatever the dawn of time is for your app, and as far in the future as you think you will conceivably need values. Now at this point, I would just kind of like you could just generate all the values out for like the next century, up to the end of this century, to the start of the next century, or even further beyond that. There's no harm in doing that. It keeps you safe and stops you running out of dates should there be any problems. So just be defensive with this. Don't play conservative. Even if you generate 3 centuries of rows, that's still like 100,000 rows in total. It's basically nothing in database terms. It's just be safe, right, with this. All right, some further reading links for those of you who want it. So live SQL scripts, whoever was asking, are the scripts available? Here's some links. We are on the hour, more or less, but I've got some time to hang around for questions. So we've got see some other comments. Let's have a look at those. So just for the sake of pure theory, maybe it's possible to use the extensible optimizer mechanism for SQL macro functions in the same way to create table functions to achieve basic cardinalities. Probably, I would have to check and look into that, Judith. If someone wants to do that, try it out, go ahead. I mean, there are various tricks you could use to get the right estimates, but it's better just to have a table, right? You're creating a lot of work for something that just happens anyway. Robberg, Frank, select trunk sysdate, the ISO week plus 1D from dual will return 1 for Monday and up to 10 for Sunday, regardless of NLS settings. So yes, a good point, Rob. So ISO weeks always start on a Monday, and you can use that fact to generate the values. Monday is 1 through to Sunday is 7, with no worries about your NLS settings. So you just need to make sure you pay attention to that. So, I mean, is a view instead of a table be a good idea? Well, with a view, you're still writing the query to having to generate those values. You could use that. You could use a view, but that doesn't really solve the problem of we need to set next Monday to be a non-working day for some reason. we don't want to have to change some code. If you use a view, you still have to change some code to do that, right? So you could use a view. A view would probably be a better alternative to a SQL macro rather than, but even it doesn't always work. You know, they serve slightly different purposes. By storing the values, you allow people to say exactly what something is. Okay. All right then. Any other? Like I say, we're just past the hour, so let's wrap up. Alrighty then. So as we saw, we want to get days in range between the start and end. We can generate those out using the connect by level trick to get however many rows we need, subtract the end date from the start, and we can normalize out that to the units that we want as well. If you want months or years, make sure you are calculating those appropriately using like add months and so on, because they are not fixed units of time. If you want to make these reusable, we can use SQL macros, but of course, you do need to be on 19C in order to do that. So more generally, a general solution which will work whichever release of Oracle database you're using, or in fact, pretty much any database you want to use anywhere, is to actually store the values in a table. And this is an incredibly useful tool, something which, you know, I'm sure once you've got it, you'll make extensive use of. So I would recommend doing this if you haven't got one already in your application. That's all I had to discuss today. I hope you enjoyed this. More importantly, I hope you learned something. Stay safe, and I hope to see you again soon. Goodbye.